Hey, welcome back. Today I'm going to be going over the next lesson for using Desmos on the math section of the SAT. And this section or this lesson here has to do with how to kind of find the key points from a graph, right? Because sometimes, right, if you just look for the right point on the graph, it saves tons of lines of algebra that you really don't have to compute. So SAT questions do, right, very often hide the answer in on the graph itself, right? Because Desmos like marks your intercepts, your intersections, your maximums, minimums, right? So like once you just know the point, right, you can often replace, like I said, several lines of algebra. So let's start with an example, so I can kind of demonstrate how powerful this is, right? Desmos. Let's say we have a quadratic expression here, right? And our goal here, right? Let's say that this function here represents the number of frog calls heard per minute. Okay, so for what value of x is this expression the greatest? So, well, if we're trying to find for what value of x that this expression is the greatest, you first have to zoom out just to get the whole picture of the graph, right? So this is the entire graph. Well, when is this entire function the greatest, right? It's going to be the greatest at its maximum point, right? In this case, the vertex is the maximum point, right? Actually, in all cases, the vertex can be either the maximum or minimum, but all you do is you click on the graph and you're going to see that there's like a point highlighted, right? That the gray points. You click on it and you can see that that point is 6 comma 82. So what does this mean? It means that 82 is the highest value that this graph attains, but it also means that it attains that highest value at x equals 6, right? So there's a key distinction. If the problem's asking you for what value of x it's the greatest, then you put 6. If it's asking you to find the maximum value, then you put 82, right? So once again, this kind of is how powerful Desmos is. It just kind of tells you what the maximum point is as long as you plot the graph and you click on the graph. So, well then, when should you actually kind of use this, right? Uh, when do you start finding key points from a graph? Well, you should always look for points while graphing when the question asks for an x-intercept, right, or a root or a zero, right? Those are kind of the same thing. The y-intercept, right, or the initial value. That's kind of also the same thing. You can also use Desmos when you're trying to find the intersection, the maximum or minimum value of a parabola, which we kind of did in this case. Uh, we can find also the input where a parabola's maximum or minimum occurs, which is kind of what I was talking about, right? In this case, that's x equals 6. Um, and once again, those are kind of the one of the basic ways you can use this. Now, you do not use this method when the question, right, already gives you a point. So, for example, right, let's say that they give me, um, and just pretend like this graphing part of Desmos is not here, right? So the equation already, let's say they give you this equation, right? And they literally tell you in the problem that the max is at 2 comma 5, right? So why am I going over this, right? Well, because sometimes, sorry, let's say it's 5 comma 2. Because sometimes you don't need to use the graph necessarily if they already give you a point. Like they already give you that the minimum is 5 comma 2, so you don't really need to graph, right? So that's kind of when you use a shorter method, like a trick. So now, a lot of the times, right, you're not always going to have X and Y, right? Like Desmos, sometimes uses another input letter other than X. They might say like T is time, right? So they might give you like, let's kind of use this first example here, or this example already here. So let's say you have 3 um, t minus 5 squared plus 2 equals, and this is function, right? Let's say it's just like f of t, right? Well, Desmos is not going to graph this because it only really likes x and y. So how do you fix this? Well, you can just replace the t with an x, right? You can kind of substitute it, and you can just keep in mind on what that value is. So again, that's not a big problem. If you can't use x, you can just use x as a placeholder or like a substitute. Okay, and the other thing I want to emphasize, right, moving on, is that one graph, and I actually kind of already stated this, it can contain multiple answers, right? If you have the graph of x squared minus 4x minus 5, right? Not only can you find the minimum point, right, which is 2 comma negative 9 here, but you can also find the y-intercept, and you can find the two x-intercepts or their roots, right? So once again, this is exactly why I love Desmos because it kind of gives you everything, right? All you have to do is just know what point you're looking for in context and translate that into the graph and click on the point. That's all. So now, right, for a parabola, right, uh, it is also possible that it never touches the x-axis, right? There might never be intercepts. But again, if that is true, then the problem probably will account for it. And once again, you can just use Desmos, right? Okay, so next thing, right, is I want to actually go over a common mistake that people actually kind of get trapped in, right? Which is that sometimes the question might ask you a very specific thing and they report another answer instead, right? So for example, let's say we have the absolute value function, this, right? We have x plus 1 and absolute value bars, right? And then plus 2. Okay, so that's your absolute value graph, right? Now, here, right? So you have another graph, y equals 5. So both of these intersections obviously have the same y coordinate, as you can tell, right? They both intersect at the same, at points with the same y coordinate, right? But they have different x coordinates, right? So if a question asks you to find like the greatest, the value of the greatest x coordinate, right? You should report 2, right? Because 2 is greater than negative 4, right? Make sure you always go back to what the problem is saying, right? Because sometimes, you might be rushing it and you're going to see like, okay, wait, negative 4, 5, that's the answer, right? Don't do that because you still have another point and you have to compare those 2 points. So and again, this is usually the case for intersections, right? That's where most people make these mistakes. Okay, so now, right, there's also the entire idea of choosing a point that fits the context, right? Say I give you a function, h of x, right? It'll probably be h of t, but again, you can replace t with x. So you can say, let's say this is negative 4 times x plus 1 times x minus 7, right? Wait, it should be a plus 1. Okay, so we're given essentially this graph, right? And once again, I told you that it would be t, right? So pretend that the x is actually a t for now, right? And let's say this function models uh, the height of a rocket t seconds after launch, right? So according to this model, how many seconds after launch does the rocket hit the ground? Well, if we're trying to find how many seconds after launch it hits the ground, well, what is the ground here? The ground here is going to represent 0 meters, right? Well, what is when does this graph hit that y value of 0? Well, at 2 locations, right? Negative 1 and 7. But the key thing to realize is that it's asking how many seconds after launch, right? Your rocket can't launch at negative 1 seconds, right? It has to start from 0 seconds, right? So your rocket starts from 0, and therefore you should only look at values after when the rocket launches, right? So in this case, right, the rocket will hit the ground at time 7 seconds, right? So once again, that's just kind of a key thing to kind of realize, right? Your answer is not going to be -1, because that's before launch. That doesn't make sense. It's going to be 7. So that's kind of a way of how you choose a point, right? Thinking about the context of the problem, right? Okay, so now sometimes you might have a graph and it's not going to be seen on the screen, right? You might start panicking. Let's say you have the graph of x minus 12 squared and then minus 4, right? So let's say you plot this graph and you don't see anything. Well, to be fair, all you can do is just scroll, like completely zooming out, and until you find a function, right? It's pretty common sense. Just find the function if you can't see it, right? So that's how you kind of make the graph visible, and you can proceed from there, however the problem asks you to do so. Um, so yeah, right. All you do is pan to the right, select the curve, and then you can just find the specific values you're looking for. And finally, right, sometimes you might have to find a solution, right? Given a function, right? So let's say I'm given the function g of x, and I think I kind of went over this in the last video, but it's always good to just be reminded of this because it's pretty important. Let's say you have the function x cubed minus 4x squared minus 7x, and then plus 10, right? So now that's our function, and we're trying to find a falling value like an x, right? Where the zero is like where exactly are the zeros of this function, right? That's what we're trying to find. Well, you should know that 0 is just a fancy way of saying x-intercept, and so you have all these x-intercepts, right? You can just click on them, right? And if it asks you to find like, okay, which of these x-intercepts are an integer, right? Well, in this case, 1 is the only integer here, so your answer would be 1. Likewise, let's say they ask you how many positive x-intercepts does this graph have? Well, once again, that would be 2, right? Because negative 3.7 is a negative intercept. 1 and 2.701, 56 are both positive. So once again, that context thing, make sure you look for the right point, and then also make sure that you're actually looking for the specific point that the problem is asking you to find. So once again, right, that's kind of an important thing. Also, just so you know, right, just identifying the roots of a quadratic or cubic expression, or even higher powers like x to the fourth, x to the fifth. Um, Now, right, a common error is that you choose 0, because every x-intercept has y equals 0, right? Well, that's not true, right? True, it is true, right? The y coordinates of all these points are 0. That doesn't mean that 0 is the answer, right? Because, well, to have an x-intercept in the first place, your y coordinate has to be 0, right? So make sure you're also looking at the correct coordinate, right? The x coordinate, not the y. So those are just kind of some of the things I wanted to go over with this lesson, right? Essentially, as long as you know how to find key points from a graph, right? Uh, you're essentially going to cover a substantial amount of material for questions that SAT asks for, right? And that again has to do with the fact that a graph tells you essentially everything, right? So I hope you found this video useful to help you in your own SAT preparing a journey. Once again, I am going to post more lessons in the future, going over some basics, so you guys are more familiar with how to use Desmos. Uh, Again, to whoever is studying for the SAT, good luck. Good luck on your tests, and I'll see you next time.